Now we're going to review a little bit about hypothesis testing before we launch into doing some hypothesis testing in some of our big examples with our large data sets. So we've seen how we can make a confidence interval using a sample. And so we made a confidence interval which was estimating where we thought our population parameter, something like the mean or the proportion, where we were pretty confident that that was. And so now we're going to continue talking about how we can use a sample to try to say something about a population parameter. So we want to try to use our sample to see what we can say about the whole population. And just some definitions before we launch into this. A hypothesis is some assumption about a population parameter. So some assumption we're making about the mean or proportion or something like that. And the null hypothesis, which we're going to denote by an H sub 0 or H naught, that represents the status quo. And it involves stating the belief that the population parameter is equal to, or at most, or at least some specific value. So it's what we're assuming is true if we don't have any other information, or maybe based on the past or something like that. And the alternative hypothesis is the opposite of the null hypothesis. And the alternative hypothesis is what we believe is true if we have enough information to think that the null hypothesis is false. So the idea is, if someone comes and tells you that the average salary at your company is $60,000 a year, and you say, okay, $60,000, well, maybe I want to try to see if that seems true. And so they tell us that the average is 60,000. I'm just going to write it as 60. And maybe you find a sample of people in your company, and in your sample, the sample average is maybe 30,000, and you asked 100 people. That's pretty far off from 60. And so that might make you question if what they told you was true, because based on your information, you got something pretty far away from that. Whereas if maybe you take a sample and you get an average that's 45,000, but maybe you only asked a couple people, that might not be enough evidence to say that what they told you is wrong. And so we want to use the tools we have to formally say, or have the tools to kind of evaluate claims like this and see what we can say with all of these statistical and mathematical tools that we have. So an example of kind of a null and alternative hypothesis is a null hypothesis. Maybe our null hypothesis is that no more than 30% of the registered voters in a particular county voted in the primary election. The opposite of that would be our alternative hypothesis, which would say that more than 30% of those registered voters voted. And so we're assuming, without any other information, that our null hypothesis is true, and then we want to look at a sample and try to see if our sample provides enough evidence to reject that null hypothesis, in which case we would think the alternative is true, or if it doesn't provide enough information to reject that null hypothesis, and the null hypothesis might still be true. So another example of this is, let's say we're doing a medical trial to test whether or not a new medicine reduces cholesterol by 25%. And I want to state my null and alternative hypothesis. So my null hypothesis here might be that the drug does reduce cholesterol by at most 25%, but my alternative hypothesis could be that the drug reduces cholesterol by more than 25%, or something like that. And so I would want to, state those statements, those hypotheses, and then I'd want to look at a sample and try to see if my sample gave me enough information to reject the null, or if I didn't have enough information to reject the null. And so how do we make those decisions? We need to be able to find our test statistic for any of these hypothesis tests that we're doing. And what our test statistic is depends on exactly what our situation is. If we're doing something for a mean and we know the population standard deviation, our test statistic will be this z-value. If we don't know the population standard deviation, it'll be a t-value. And if we're doing things with proportions, it will be a z. And where these come from, we're not going into all of the details of those. Those are things you've seen before in statistics classes, where you learned about like the central limit theorem, all that good stuff. We're just going to see how we use these things. So an example of kind of how this would come up, let's say that my null hypothesis is that my mean is at most 7. Then my alternative hypothesis would be that the mean is bigger than 7. That would be the opposite. And let's say that I'm in this situation where I know the population standard deviation. Then I would be able to find my z-value, my test statistic, and let's say I got a test statistic, a z-value that was really big. So let's say, I don't know, really big, maybe 4. So that is quite a few standard deviations away from the mean. And so the idea here is that if I think about my standard normal distribution, I got a z-value of 4. That's pretty far over here. It might even be farther than is in my picture here. And I want to see the probability of being at least that far away from the middle. And here, if I look at my alternative hypothesis, I'm only looking to the right of 7. And so when I do my probability, I only care about what happens to the right. This is what we call a right tail test. And so what I would want to do is find that probability, that area to the right. And we give a name to that probability. The p-value, or a p-value, is the probability, assuming that the null hypothesis is true, of getting a random sample of size n that results in a test statistic at least as extreme as the one observed in the sample. So let's say that I'm assuming that my population mean is 7, and I take my sample and I end up getting a test statistic of 4. So a z-value of 4. The p-value would be the probability of having a sample of that size and getting something that far away from 7, assuming the mean actually is 7. And so if this is a super tiny probability, that would mean that the sample that I chose was really unlikely to happen. And it happened. And so if I get a really tiny probability, that might lead me to say, I don't think the null hypothesis is true, and so the alternative hypothesis might be true. Whereas if I get a reasonable probability, maybe the probability is 30%. And it's like, okay, so that's not the most likely thing, but it's definitely still possible. That might not be enough evidence to reject the null hypothesis. And we always have to decide what that cutoff is for us, for what is too small and what's not too small. And we're going to usually call that cutoff alpha. And so next, we're going to look back at this census data from October of 2023, and we're going to do a hypothesis test about the proportion of households in which, this should say someone, owns a business or a farm. And so we're going to look at that data and see how we could actually do this hypothesis testing for a real example like this.